Hey everyone, welcome. I've got a really cool secret to share with you today. A secret about numbers. Did you ever stop and wonder what numbers are actually made of? Yeah, I know it sounds a little strange, but just like a house is built from bricks, numbers are built from these special little pieces. It's like they have a secret code. And today, we are going to learn how to crack that code. You ready? Let's do this. Okay, so let's start with a really, really simple idea. Just look around you. Pretty much everything you can see is made of smaller parts, right? Take this little drawing of a house. What is it? Well, it's just a square and a triangle put together. That's it. These simple shapes join up to make something totally new. Let's check out another example. How about words? Every single word, no matter how long or short, is just made from our 26 letters of the alphabet. So the word math, for example, well, it's just M-A-T-H. These letters are like the building blocks for every single word we read and write. And guess what? It's the exact same idea in science. See this glass of water? It looks like water, just one thing. But if you could zoom in with a super powerful microscope, you'd see it's actually made of tiny, tiny pieces. These are called elements. Water is made from two of them, hydrogen and oxygen. So even here, we have building blocks for everything in the whole world. Okay, so this leads us to the big question, right? We know words have letters. We know water has elements. So what are numbers made of? Did they have building blocks too? The answer is yes, they totally do. And finding those building blocks is exactly what we're going to do today. All right, here's our game plan. First up, we'll figure out what these number building blocks actually are. Then, we'll learn about two different types of numbers, prime and composite. After that, I'll show you a really cool way to find those prime numbers. Then we'll get into the fun part, finding a number's secret recipe. And finally, we'll see why any of this actually matters. Sound good? Let's jump in. Okay, let's get into it. Part 1, the building blocks of numbers. So to find these building blocks, we're going to need a special tool from our math toolbox. It's a super important idea, so let's check it out. So this key tool is called a divisor. A divisor is just a number that can divide another number perfectly. And by perfectly, I mean with nothing left over, no remainder. Let's try an example. Think about the number 12. Can you divide 12 by 3? Yeah, 12 divided by 3 is exactly 4. It works out perfectly. So we say that 3 is a divisor of 12. What about 2? Is 2 a divisor of 12? Yep, 12 divided by 2 is 6. Perfect again. Now, what about 5? If you do 12 divided by 5, you get 2, but then you have 2 left over. See? There's a remainder. That means 5 is not a divisor of 12. Getting this idea of a divisor is the absolute first step for us. All right, now that we've got the hang of divisors, let's move on to part 2. We're going to use this idea of divisors to sort numbers into different piles. It's kind of like being a detective and sorting through clues. This is where it starts to get really interesting. Okay, let's check out this table. We're looking for a pattern here. So in the first column, we just have numbers 1 through 9. The second column shows every divisor for that number, and the last column just counts them up. Let's go through it. For the number 1, well, it only has one divisor, itself, 1. So the count is 1. Okay, now the number 2. What are its divisors? Just 1 and 2. That's a count of 2. How about 3? Its divisors are 1 and 3. Again, a count of 2. Interesting. But look at 4. Its divisors are 1, 2, and 4. That's 3 divisors. And look at 6. It's got 1, 2, 3, and 6. That's 4 divisors. Are you seeing a pattern in that last column? Some numbers have exactly 2 divisors, and some have more than 2. This is a huge clue for us. So that pattern we just spotted? It lets us split our numbers into 2 big groups. Over here on the left, we have the numbers with exactly 2 divisors, like 2, 3, 5, and 7. And on the right, we have the numbers with more than 2 divisors, like 4, 6, 8, and 9. And in math, these 2 groups have very special names. So those numbers that have exactly 2 divisors, the special ones, they get a very cool name. We call them prime numbers. Can you say that? Prime numbers. A prime number can only be divided by 1 and by itself. That's it. And guess what? These prime numbers are the secret building blocks we've been looking for all along. They're like the letters for our number alphabet. Okay, so what about that other group, the ones with more than two divisors? We call those composite numbers. Let's say that too, composite numbers. And it's a great name because compose means to build something. And that's exactly what composite numbers are. They're built from our prime number building blocks. They're like the words we make from our letter blocks. Hang on a second. You might be wondering, what about the number 1? Where does it fit in? Let's think about it. To be a prime number, you need exactly two divisors. How many does 1 have? Just 1, itself. So nope, it's not prime. Okay, is it composite then? Well, to be composite, you need more than two divisors. So it's not composite either. The number 1 is special. It's neither prime nor composite. It's just in its own little category. All right, let's dive into part 3. So we know what prime numbers are, but how do we find them? I mean, we could test every single number, but wow, that would take forever. Luckily for us, a super smart guy in ancient Greece, his name was Eratosthenes, came up with an amazing trick. His method is called a sieve, like what you use in the kitchen to strain spaghetti. We're going to use his math sieve to catch all the prime numbers. Okay, let me show you exactly how this sieve works. I'll go nice and slow. First step, we get our grid of numbers. And right away, we cross out 1. Why? Because we already know 1 is not prime. Easy enough. Step 2, we find the first number that's not crossed out. That's 2. We know 2 is prime, so let's circle it. Now the fun part. We go through and cross out every multiple of 2. So goodbye 4, 6, 8, 10, all the way down the line. Okay, step 3. What's the next number that's not crossed out? It's 3. So 3 must be prime. Let's circle it. And you guessed it, now we cross out all the multiples of 3. So 9, 15, 21, they're all out. Step 4, we do it again. The next one up is 5. We circle it because it's prime, and we cross out all its multiples. See the pattern? We just keep going. The next prime is 7, we'd circle that and cross out its multiples. And when you're all done, whatever is left with a circle around it, those are your prime numbers. It's such a clever way to find them. Welcome to part 4. Okay, this is where everything we've learned comes together. We know what primes are, we know how to find them. Now for the really cool part. We can take any composite number and find its secret recipe, the recipe made of only prime numbers. And this awesome process has a name, prime factorization. Now before we jump in, let me show you a quick little shortcut. It'll just make our writing a lot cleaner. Sometimes a recipe might have the same number multiplied over and over, like 2 times 2 times 2 times 2. Writing that out is a bit of a pain, so math has a shortcut called an exponent. Instead of all that, we just write a big 2 with a tiny 4 floating up next to it. That little 4 just means multiply 2 by itself 4 times. It's just a neat way to write things. So, prime factorization, what is it? It's the process of taking a number and breaking it down and down and down until all you have left is a string of prime numbers being multiplied together. And here's the coolest part. Seriously, every single composite number has its own unique prime recipe. No other number in the universe has the same one. It's like a fingerprint, but for numbers. Okay, let's do one together. Let's find the secret prime recipe for the number 60. Ready? Step 1. We start with 60. Step 2, we always start by trying to divide by the smallest prime number. And what's that? It's 2. Can 60 be divided by 2? Totally! 60 divided by 2 gives us 30. Step 3. Now we're at 30. Can we divide by 2 again? Yep! 30 divided by 2 is 15. Okay, step 4. Now we have 15. Can we divide 15 by 2? Nope, not without a remainder. So we move to the next prime number, which is 3. Can 15 be divided by 3? Yes, it can. 15 divided by 3 is 5. Final step, we're left with 5. Now, is 5 a prime number? Yes, it is. Once you get to a prime number, you're done. So the prime recipe for 60 is 2 times 2 times 3 times 5. And using our cool exponent shortcut, we can write that as 2 squared times 3 times 5. Awesome, we found it. You guys are doing an amazing job. We are at our final section, part 5, why this matters. So we've learned how to find the secret recipe, but you're probably thinking, so what? Why do I need to know this? And that's a great question. It turns out this is an incredibly powerful tool. Let's see what it can do. So now that we have a numbers prime recipe, what can we actually do with it? What's the point? Okay, here it is. This is the superpower. Once you know the prime recipe, you can easily find all of a number's divisors. Every single one. No more guessing. Remember how we had to test numbers one by one at the beginning? We never have to do that again. We can just use the recipe to build them. Let me show you. Let's use the number 12 as our example. First, what's its prime recipe? It's 2 times 2 times 3, or 2 squared times 3. So our ingredients are 2 2s and 1 3. Now, check out this table. Along the top, we'll put all the combinations we can make with our 2 2s. We could use no 2s, which is just 1. We could use 1 2, or we could use both 2s, which is 2 times 2, or 4. Got it? Okay, down the side, we do the same for our 3s. We can use no 3s, which is 1, or we can use 1 3. Now we just multiply to fill in the grid. 1 times 1 is 1, 1 times 2 is 2, 1 times 4 is 4. Moving to the next row, 3 times 1 is 3, 3 times 2 is 6, and 3 times 4 is 12. And just look at that. The numbers inside the table, 1, 2, 3, 4, 6, and 12, are all the divisors of 12. We found every single one, no guessing, just by using the recipe. How cool is that? And you know what? Finding divisors is just the beginning. It's only one of the superpowers that these prime numbers have. These unique prime codes, they're actually used for really important stuff, like making sure your information is safe and secure on the internet. That's a field called cryptography, and it's all built on this very idea. It kind of makes you wonder, right? If these simple building blocks of numbers can do all of that, what other secrets could they unlock? Thanks so much for joining me today and exploring this amazing part of math.